Hello everyone, welcome to this video. In this video, we are going to see how to solve the type 1 homogeneous linear PDE. So in the last video, we saw that we know our general homogeneous linear PDE of nth order will be in this form. F of d comma d dash is equal to function of x and y. So in the last video, we saw that suppose if the right hand side function is 0, then we have only the left hand side f of d comma d dash into z. For this we can find only complementary function, and complementary function alone gives the complete solution, because the complete solution is z is equal to cf plus pi for any homogeneous linear PDE. Suppose there is no right hand side, then complementary function alone gives the particular complete solution. Suppose if our right hand side function is non-zero, means if we have some function of x and y in the right hand side, what happens and how to find its particular integral, that what we are going to discuss in this video. So the right hand side function may be any function, that may be an exponential function, or that may be a trigonometric function, or that may be an algebraic function. So in type 1 we are going to see, suppose if the right hand side function f of x comma y is an exponential function in this form, say e power ax plus by, then how to find the particular integral to the given equation. So for this case, we replace this for finding the particular integral. First we take our function of x and y in the numerator and the function of d and d dash in the denominator. So this is what the first step we have to do, and then this d is replaced by this a, and then this d dash is replaced by b. So the denominator becomes f of a comma b, and if that f of a comma b is non-zero, means your particular integral is obtained. You can stop the procedure there itself, and the resultant gives the particular integral. Suppose if f of a comma b is non-zero, means further you have to proceed. That is, you have to differentiate the denominator function of d and d dash with respect to d. Okay, once, and then you have to apply the same procedure for, you have to take x in the numerator. Suppose again the denominator becomes 0, then you have to go for the second differentiation. So you are taking x square by 2 factorial in multiplication of the function, and then you apply the procedure again. Suppose if you are uh, after substituting d as a and d as b, again that f of a comma b is 0 after second differentiation, means what? You are going for third differentiation. Okay, so there you will multiply the function by x cube by 3 factorial, so and so on. So like this you are proceeding till the denominator term f of a comma b is non-zero. So now let us see some examples for this. So this is our first example. So first we are going to rewrite the given equation in the form f of d comma d dash into z is equal to function of x comma y. That is, in the left hand side it is d cube minus 3. Here we can take this as dou square z by dou x square and dou z by dou y. So the middle term is 3 into d square into d dash, plus the last term is 4 into d dash cube into z is equal to e power x plus 2y. So first we have to find out the complementary function by considering the left hand side, and after that by considering the right hand side we can find our particular integral. So first, for finding the complementary function, that is to find CF, we write the auxiliary equation. So the auxiliary equation is obtained by replacing d by m and d dash by 1. That is, the auxiliary equation is f of m comma 1 is equal to 0. So now I'm going to take d as m and d dash as 1 in my function of d and d dash, and I'm going to equate that to 0. So it comes as it comes as m cube minus 3m square plus 4 is equal to 0. So it's a cubic equation. So I'm going to use synthetic division to solve this cubic equation. So here the coefficients of the terms are 1, minus 3, and coefficient of here m term doesn't exist, means what? The coefficient of m is 0 and then the constant term is 4. Since I'm having the constant as an even number, I'm going to check whether 2 satisfies this equation. So always here we put 0 and 1 plus 0 is 1. 1 into 2 is 2 and here it is addition gives minus 1 and here product gives minus 2. So addition gives minus 2 and product gives minus 4. Yes, 2 satisfies this equation because we get the remainder as 0 here. So one of the root is m is equal to 2 and we get one quadratic equation, m square minus m minus 2 is equal to 0. So solving this we can find the remaining two roots, that are minus 2 is 1 into minus 2 because the product must be minus 2 and the sum must be minus 1. So the other two roots are m is equal to minus 1 and m is equal to plus 2. So that is we get from this m is equal to minus 1 and 2 comma 2. So these are the three roots we get from this, and here one of the root is distinct but the other two roots are equal. So here how can we write our complementary function? For this our CF is equal to phi1 of y minus x plus phi2 of y plus 2x plus x into phi3 of y plus 2x. So now let us go for finding the particular integral. For we consider the right hand side. So to find pi, we take our function in the numerator, that is e power x plus 2y, and our function of d and d dash in the denominator. So which is d cube minus 3d square plus into d dash plus 4 into d dash cube. So here for type 1 we are replacing d by a and d dash by b. So we have e power ax plus by form. So our a is 1 here and b is 2. So here we have to replace d by a and d dash by b. So this gives e power x plus 2y by replacing d by a, it is 1 minus 3 into 2 plus 4 into d dash is 2, so 2 cube is 8. From this we get e power x plus 2y by 1 minus 6 plus 32 and it is equal to 27. So the particular integral is e power x plus 2y by 27. So now we can write the complete solution z as CF plus PI. So together CF and PI gives the complete solution. So finally we have to write our CF plus PI as our complete solution. So our second problem is d cube minus 7d d square d dash square minus 6d dash cube into z is equal to e power 2x plus y. So first we are going for finding the complementary function. So to find the CF, first we write the auxiliary equation. The auxiliary equation is m cube minus 7m minus 6 is equal to 0. Again we have a cubic equation. So I'm going to follow synthetic division here to solve this. So it is 1 0 and minus 7 and minus 6 because coefficient of m square is 0 here because there is no m square term here. So here also I'm having an even number. Let me check whether 2 satisfies this. And it is 0, 1, then 1 into 2, 2, then it is 2, and then it is 4. Then I'm getting minus 3 and it is minus 6. But I want plus 6. So I can put minus 2 here. So if I take minus 2, what I'm getting then, if I take minus 2, it is here minus 2, so minus 2, so it is plus 4, that is what I'm getting, plus 4, that is minus 3, then again it is plus 6, so it is 0. So minus 2 satisfies this equation. So one of the root is m is equal to minus 2, and then we get a quadratic equation, that is m square minus 2m minus 3 is equal to 0. Solving this, we can get the remaining two roots. So here it is product must be minus 3 and the sum must be minus 2. So the other two roots are minus 1 and plus 3. So m is equal to minus 1, minus 2 and 3. So these are the three roots for the given equation. So and all the three roots are distinct. So we can write our complementary function as phi 1 of y minus x plus phi 2 of y minus 2x plus phi 3 of y plus 3x. So now let us come to find the particular integral. So to find pi, we take our function, right hand side function in the numerator, it is e power 2x plus y, and the function of d and d dash in the denominator. So it is d cube minus 7d dash square minus 6d dash cube. So here our a is, we have e power ax plus by form. So our a is 2 and our b is 1. So here we are going to replace d by 2 and d dash by 1. So in the denominator, when you replace d dash by 1 and d by 2, we get, it is 2 cube is 8 minus 7 into 2, that is 14, minus 6 into 1. So which gives the denominator as non-zero, that is e power 2x plus y by 2x plus y by it is minus 20 plus 8, so it is minus 12. So we have got our particular integral as e power 2x plus y by minus 12. So finally we have to write the complete solution as, that is cf plus pi, which is phi 1 of y minus x plus phi 2 of y minus 2x plus phi 3 of y plus 3x, and then minus e power 2x plus y by 12. Okay, now let us move on to the next problem. So this is our third example. So here we have d power 4 minus d dash power 4 into z is equal to e power x plus y. So first we need to find out the complementary function. So to find CF, we write the auxiliary equation first. So the auxiliary equation is m power 4 minus 1 is equal to 0, and this can be written as, since we have a square minus b square form, this can be written as m square minus 1 and m squared plus 1 is equal to 0. And solving this, we get m square is equal to 1, implies that we get m is equal to plus or minus 1, and m square is equal to minus 1 implies that we get m is equal to plus or minus I. So here all the four roots are distinct, so our CF takes the form phi 1 of y minus x plus phi 2 of y plus x plus phi 3 of y plus ix plus phi 4 of y minus ix. So now let us come to find the particular integral. So to find the particular integral pi, we take our function f of x plus f of x comma y, which is given the right hand side in the numerator, and our function of d and d dash in the denominator. So it is d power 4 minus d dash power 4. So here we can't substitute our a and b directly because that becomes 0. Okay, so that is see here. If you take here, we have e power x plus by, and our A is 1 and B is also 1 here. So if you replace directly means you are getting 0. So what you will get here then? When you replace d by 1 and d dash by 1, we are getting the denominator 0. So we have to take x in the numerator and then we have to differentiate the denominator with respect to d alone. So it is 4d cube. So now when you replace d as 1, okay, so you get x by 4 into e power x plus y. That is our particular integral is x into e power x plus y by 4. So here we have replaced d by 1 now. So that comes as 4 into 1. So that is 4 only. So this is what our particular integral. So finally the complete solution can be written as the complete solution is z is equal to CF plus PI. So CF together PI, CF together PI, we write our complete solution. So this is our next example. It's example 4. Okay. So here first we are going to find the complementary function by considering the left hand side. So to find the CF, first we write the auxiliary equation. So the auxiliary equation is m cube. First we'll rewrite the given equation. So we'll rewrite the given equation in the form of f of d comma d dash into z is equal to f of x comma y, for it is d cube minus 2 into d cube minus 2 into it is d square into d dash into z is equal to e power x plus 2y. So now the auxiliary equation can be written as m cube minus 2m square is equal to 0. So we can take m square outside from this. So it is m square into m minus 2 is equal to 0. So the roots are m is equal to 0 comma 0 and 2. So here the first two roots are the same repeated and the last one is distinct. So we can write our complementary function as CF is phi 1 of y plus 0x, that is phi 1 of y plus x into phi 2 of y plus 0x, that is y, plus phi 3 of y plus 2x. So now let us find the particular integral. So to find the particular integral, we take our function of x and y, that is e power x plus 2y in the numerator, and the function of d and d dash in the denominator. So which is d cube minus 2d square d dash. So here our a is equal to 1 and our b is equal to 2. So we are going to replace d is equal to 1 and d dash by 2 in the denominator, which gives e power x plus 2y by, replacing d by 1, it is 1 minus 2 into, and d square is also 1 into d dash is 2. So it is 1 minus 4, that is minus 3. So minus e power x plus 2y by 3. So the complete solution can be written as solution is z is equal to CF plus PI. Okay. So this is our last example. So here in the right hand side we have a hyperbolic function which is not an exponential function, but for this hyperbolic function also we can apply the type 1 rule because this can be expressed in terms of an exponential function, right, using the formula. So here first to find the CF, to find the CF we write the auxiliary equation. The auxiliary equation is m squared plus 2m plus 1 is equal to 0. And solving this we get the product must be 1 and the sum must be 2. So here it is 1 into 1, so it is m plus 1 into m plus 1 is equal to 0. So the roots are minus 1 and minus 1, that is the roots are repeated, right, repeated. So how to write our CF? So CF is equal to phi 1 into y minus x plus x into phi 2 of y minus x. So now to find the particular integral, to find pi, we take pi as the function of x and y in the numerator, that is sine h of x plus y, and our function of d and d dash in the denominator, which is d square plus 2d d dash plus d dash square. So now we are going to use the formula for sine hx. We know that sine hx is e power x minus e power minus x by 2. So using that, we can write the particular integral as e power x plus y minus e power minus of x plus y by 2. And in the denominator we have d square plus 2d d dash plus d dash square, and we can separate this term. So it is e power x plus y by 2 into d square plus 2d d dash plus d dash square, and the second term is e power minus of x plus y by 2 into d square plus 2d d dash plus d dash square. So here the first we are going to replace d by our a and b both are 1, but in the second term our a and b both are minus 1. So in the first term we are going to replace d by 1 and d dash by 1. Similarly in the second term we are going to replace d by minus 1 and d dash by minus 1. So now substitution of this gives in the first term it is, when you replace d by 1, here it is denominator is 1 plus it is 2 plus 1, okay, the denominator, and here it is 1 minus 1, the whole square is 1, and here d and d dash both are minus 1, so that comes as plus 1, so it is plus 2, and d dash square is again plus 1. So when you replace d by a and d dash by b in both the terms, you are getting the denominator as 4. So how can we write it finally? And so I can take that 1 by 4 outside, because I'm having again this e power x plus y minus e power minus of x plus y by 2. So this is nothing but sine h of x plus y. So the particular integral is sine h of x plus y by 4. That is the difference here. So the complete solution z is nothing but CF plus PI. So which gives the complete solution. I hope you understand how to solve the first type of homogeneous linear PDE. Thank you.